Chemistry Thoughts Part 2. These are the objectives. So this is from the Cartoon Guide. It's an awesome book. I wish it was our textbook, but that's hard to justify to the higher-ups that we need to get cartoons. But that's okay. So I have a lot of things in here. So, like, scientists, they basically heated up a bunch of rocks. They found out that these green rocks, when you heated them up, this orange hot metal came out, and that's copper. And that's what caused civilization. Chemistry is responsible for us going from nomadic hunters to being able to have cars. Because we were able to extract like metals and stuff we need from the rocks. So chemistry is real important. It's why you're here. It's why we have soap. It's why we have vaccines. It's why you guys have hats. Maybe not why you have hats, but why you have the materials that make the hats. All right? So, hold on. Actually, you guys don't take this down. So, what we did in the penny demo, we turned a copper penny into a gold penny. What we really did is we did a series of chemical reactions and physical reactions in order to move around the atoms to look different. So we took the zinc, had a chemical reaction. Eyes up here. Pay attention, everybody. And we moved those zinc atoms by chemical reaction to the copper. And then we mixed them up. We moved them around, so that's physical. So this is what I want you guys to take down. I'll pause it. Chemical changes occur when a new substance is formed. So we have a different substance than we started with. And how that happens is atoms are bonded in different ways to new atoms than when they started. And we have that new particle that wasn't there in the beginning. That's the key thing about a chemical change. This first one, a new substance is formed in a chemical change. That's very important. A physical change, you have the same substance. The atoms are bonded in the same groups that they started with. And they move around, though. They have a different position. I like to think about it, the P's. Physical starts with a P. Particles, position. Particle, position, physical. All the P words. Particles change position in a physical change. Okay? That's the key thing. Chemical changes are the new substance. We got something new. So, like, if you, like, burn gasoline, you don't have gasoline anymore. You have carbon dioxide and water. That's a chemical change. Start off with gasoline and oxygen, end up with carbon dioxide and water. You have new substances. But if I, like, let's say I tear your paper, do I still have paper? Yeah. It's still paper. That's a physical change. I'm moving the paper particles around, but it's still cellulose, compressed cellulose, I guess what you call it. Physical changes. So what I mean by a chemical equation is up here. This top thing is a chemical equation. You guys know it's called what you start with in a chemical reaction? What do you call those things? That part. You understand? No? It's called the reactant. So what you're starting with is called the reactants. What is it called? What you produce? Products. So evaporation is when H2O liquid becomes H2O gas. Right? So H2O liquid becomes H2O gas. What's happening there? What particles do I start out with?
They moved.
They moved around. But did the particles themselves change? No. No. They moved around. So they're changing their position, but they're the same particles. That's why it's a physical change. If I hammer some copper, if I make it thinner, what happens to the actual particles of copper? Oops. What are they doing? Are they changing or are they moving around? They're moving around. So that's why it's a physical change. You don't have any new substances. What about when I burned it and made it copper oxide? What was that? Nope. When I burned it, I started with copper particles and oxygen, and then I made copper oxide particles. That would be a chemical change. So Take a look at this diagram up here. Hydrolysis. Eyes at the board, guys. We're almost done, I promise. What do we start with? What particles do we start with?
Water.
H2O, water. What do I end with? Hydrogen and oxygen. Do I have the same type of particles?
Yeah.
No. I start off with water particles. I start off with oxygens connected to hydrogens. What do I end up with? I have hydrogens connected to each other and oxygens. So they're formed in a new way. The atoms are like taken apart. Same thing with combustion. Start out with CH4 and O2, and I make CO2 and H2O. I have different substances. Methane, which is natural gas, and oxygen. That's what I'm starting with. And I'm ending with carbon dioxide and water. So you guys can imagine. Imagine this. Imagine an atom is like a Lego, a specific type of Lego. And in order to make a new thing, you have to take them apart and put them together in a different way. So that's like a chemical change. A physical change is if just you have your Legos already assembled and you're kind of moving those around and playing with them. So like if you separate the Legos, you're not taking any Legos apart, you're just moving the things you already constructed around. That's physical change. A chemical change is when you actually take apart your hydrogen Legos from your oxygen and you put the hydrogen Legos together. That's a chemical change. So I think we're running out of time, guys. We'll do a warm-up on tomorrow. And guys, can you guys put the chairs up? Because I'm teaching in the other room next class.